Hello, and welcome to Cloud Safeguarding, View from Cloud Providers. I'm Britta Glade, Director of Content and Curation for RSA Conference, and I'll be the moderator for this session. First, a bit of housekeeping. If you're joining us live, our panelists are in the Slido chat discussion area answering your questions right now. For audio or video issues, click the technical support button below. I'm joined today by three fantastic experts. Miles Hosford is Principal, Head of Security Architecture, ASEAN, AWS. Mark Johnston is APAC Head of Security for Google, and Abbas Kudrati is the Chief Security Officer, APJ, for Microsoft. Our session and the questions we'll be exploring today are based on dialogue and work that RSA Conference has done with the CISO community, zeroing in on concepts and questions that have been raised by this important community. We've broken our conversation today into three key areas with a few questions that each of our panelists will be addressing, with a goal of equipping you with some good strategies and best practices for cloud safeguarding. I'll start our discussion today with the first question directed to all of our panelists, starting with Mark, and then Miles, and then Abbas. Mark, what are the top 3 to 5 security benefits to an organization for moving to a public cloud environment?
Thanks, Britta. And for me, number one has to be resource optimization. The ability to remove tasks that provide high toil, but low business value to your organization, like patching firmware or underlying compute infrastructure or networking equipment that is not always easy to manage. Tracking models and vendors and vulnerabilities or CVEs across your fleet of infrastructure. This reduces the attack surface area that you need to monitor, manage, and protect, and allows you to optimize those valuable security resources and skills that you just can't get enough of to protect your organization. Secondly, resilience and availability. High availability and disaster recovery are really challenging aspects and often extremely expensive. With cloud services, they're configuration items, not complex procurement and finance discussions. Your ability to leverage the hyperscale defenses like distributed denial of service, massive network interconnect resiliency, multiple zones and regions, these are spun up and spun down with very little lead time or capital expenditure. And lastly, those CSPs have huge investments in security itself, much larger than many enterprises can afford to spend themselves. You're able to leverage the native investments they've made in their platform and the partnerships they've made with third-party technology providers to bring some of your existing technology and security stack to manage in the way you want to, as well as leverage some of the built-in security capabilities, such as encryption standards and strengths that they bring to their services consistently, such as native logging capabilities that have always been traditionally harder on-prem. And I'll pass to the next person.
Miles.
Thanks, Britta. Thanks, Mark. And I'm going to go for 3 benefits also. And I think my first one will echo what Mark closed with there around the investments that cloud providers make in their security posture. You'd probably hear of that being called the shared responsibility model, potentially, where the cloud providers are responsible for hundreds of controls across their environment that you as a customer automatically benefit from on day one of using the platform. So if you move a proof of concept application or a mission critical application to AWS on other cloud providers like Google and Microsoft, you already benefit from those controls that already exist. Typically, those controls would be audited by third-party auditors, giving you the assurance that those controls meet your high standards and expectations. The second benefit that I'd like to focus on, and it's really one that I think is fantastic for customers moving to public cloud, is the level of visibility that security organizations get from their environment. Now, typically, or on-premise environments, it's very hard to get insight into all of the different activity across your networks and application stacks. So as developers and engineers are making changes, historically, security teams have struggled collecting all of those different data sources and analyzing what's happened in their network. In a cloud environment, it's very easy to determine what's happened, who performed the activity, and what was the result of that change. So for example, if someone makes a modification to your network, alters your firewall settings to expose vulnerable service to the internet, very often that sort of activity can be detected very, very fast and responded to in real time. Which takes me on to my third benefit, and something that I think you'll hear from most of the speakers today around the use of automation to protect your cloud environment. Now, cloud is essentially a collection of APIs. And because it's APIs, you can move to an event-driven security model, which can be reactive and protect your environment against threats and incidents as they happen. So my earlier example of someone modifying a firewall setting or changing a network, if you have the visibility to detect that in real time, combined with the automation and the event-driven security via APIs, you can essentially remediate these security misconfigurations and incidents as they happen in your environment and not have to wait kind of weeks or months to determine that these events have occurred like you would traditionally in an on-premise environment. Over to you.
Excellent. Abbas.
Thank you, Mile and Mark. I think I would echo all the points which you covered, and I think that's a similarity of most of the cloud service provider. But I thought I'll share my perspective, being ex-Chief Information Security Officer, the things which I used to more focus on when I had everything on-premises, right? Take an example of a threat management. So I had to wait until my vendor will issue the patch, and I need to work around with multiple vendors to fix something if I have a threat or any malware infection in my network. But today, if I'm using the cloud-based solution, could be a cloud-based EDR, I can use the power of cloud and get quickly remediated because they are protecting at a very hyper scale or at a speed, right? When it comes to threat management, the minutes matters. So you need to have something which can be immediately remediated across the world. And we have seen those examples of some of the big ransomwares and malware, such as Bad Rabbit. Second one being a CISO, I had a huge challenge of how do I maintain my compliance requirement for a number of regulatory bodies in my company. But having now working with passing those responsibility towards the cloud service provider, they are now taking care of most of the control when it comes to the compliance requirement. Could be ISO 27001, could be PCI DSS, or could be my APRA requirement in Australia as such, right? So I can take advantage of shifting the responsibility of compliance and security towards my cloud service provider. Third being having a flexibility of elasticity and pay as you go. I don't need to make a huge investment in infrastructure and security product right from the beginning, because as you know, we buy your security solutions and we hardly use 25 to 50% of the capability, and rest of the capabilities are not even being utilized, and we pay 100% of the cost. And having those features now with the cloud, you pay for the features which you're using it rather than paying 100% to those areas. So which gives a huge advantage to the CISOs, saying that in terms of how much they can utilize, they can use the investment for something different, and having that flexibility of using those built-in security within the cloud service provider ecosystem. And last but not the least, I think we all have agreed, all spoken about is investment which cloud service providers make, right? You don't need to worry about having data center security as an example, all the CCTV cameras and biometrics and whatnot. All these things are now transferred to them. And Mark talked about a firmware level security. Hand on heart, if you ask any CISO, how many times do they do a firmware level patches? You will not get the answer as a yes. They ignore it. And we have seen in the past, right? We have seen NotSoPatia, which was targeting at a firmware level. But now that cloud service provider is managing your VMs and everything as an infrastructure of service, they take care of firmware level security. So you can sleep well in the night as a CISO, right? Over to you, Brita.
So for our next set of 3 questions, we'll direct the conversation to Abbas and encourage all of the rest of you to participate in Slido in the discussion with all of our panelists who are here. Abbas, how should a CISO organization staff for cloud security? What are the various roles across architecture, engineering, and operations required for success?
Absolutely. Thanks, Rita. So as we have seen, the whole journey from on-prem to cloud is transforming, right? And we call it from legacy to cloud. And we have seen the evolvement in architecture space, the tooling, the skills and practice. And if you look at the few of the changes, what we see is the architecture is changed, but the principle and outcome still remains the same. When it comes to roles and responsibility, the skills will evolve, right? And same thing goes with the control. The control and tools and process will also evolve. And also, some of the roles will still remain the same, some will change, and some roles will be completely new. As we have seen that now we will be running a kind of a dual perimeter, right? Every organization who is now doing a shift from on-prem to the digital transformation or to the cloud journey, they will have a classic perimeter, as we call it, the network-based control. And there is another perimeter, we call it, which is a modern perimeter, which is an identity-based control. And that's why we are seeing the evaluation of those various roles and responsibility from a legacy architecture and operating model to a modern architecture and operating model. To give an example, the security role, which has been shifting now from a manual resource administration, which is our admin used to do it, they are now focusing on being an author and governing and more automation part. Similarly, our network team, which was focusing on a network containment, now they are focusing on containment at all the layers, which includes network, application, identity, data, and whatnot. Similarly, the development team, which was focusing more, or security team was more focused with development team on a quality check before release. Now they are working as an SME in a DevOps process and a DevSecOps process and a continuous evolution-based project. Our architecture team, which used to be more focused on a project-based engagement before, now they are focusing on a continuous engagement and a continuous improvement. So the kind of new role which we are seeing is Business Information Security Officer, or a BISO as we call it. We are seeing more of a cloud solution architect, the cloud security architect. We are seeing the new roles popping up based on identity and access management, which is IDM specialist, as we are talking about identity as a new perimeter. We are seeing a specific security analyst, which are focusing on cloud-based threats and cloud-based alert, right? Before the focus of security analysts was more network-centric and on-prem. Now they need to understand the threats coming from cloud. So there is a set of skill set which are required and focusing on cloud-based threats, and we call it cloud security analyst in that area. So these are some of the new things and the evolution of roles and responsibility which we are seeing when things are moving, when our organization is now changing, especially for information security officer. Over to you, Brita.
Thanks, Abbas. So for the next question, if you could address for me, why is it important to understand shared responsibility when moving to a public cloud environment?
A very good question, I would say. And shared service responsibility goes a long way with all the cloud service provider, what we have here. But one thing we need to really understand is responsibility versus accountability. And I like the analogy of a bank, right? So where you go to bank to keep your money safe, right? You go and deposit the bank will take care of the money. But how you spend is your call. That's where the accountability comes in, right? So yes, cloud service providers are having a model based on the service which you use, could be infrastructure as a service, platform as a service, or a software as a service. And the cloud responsibility keeps changing. The responsibility of the security and other areas keeps changing based on the service what you use. For example, if you are using just infrastructure as a service, then physical layer and to hardware layer is the responsibility of service provider. And if you are using the software as a service, then everything from physical layer to operating system layer to application patches, all those responsibilities are shifted towards them. But we need to understand that you are the responsible for identity and the data. The cloud service provider is not going to take responsibility of how you classify the data. Yes, they provide you all the controls and technology built in for managing those security, but you need to define in terms of what my data classification is based on the sensitivity and criticality, how am I going to store it, where do I store, archive, and all those things, including encryption. And the second important part is identity and access management. Who are you going to provide the access to them, role-based access control, or any other mechanism you have. So you need to really understand in that area, right? And you are using those enriching signals from them. So if your cloud service provider is giving you access to the APIs and collecting those signals and alerts and pushing it back in your on-prem SIEM or a cloud-based SIEM, then the monitoring responsibility also relies joint responsibility. There are certain things which cloud service provider takes care for you, but there are areas of monitoring and alerting which you need to configure and use it on your side. So understand the built-in of security control which they provide, but Mark talked about in the initial pitch, the configuration part, right? You are still responsible for fine-tuning it, configuring it, and managing it in your environment the way you want to use it. So, yep, you have the keys, but how you keep those keys safely, it's your responsibility. Example of, you should not keep your keys under the doormat. You have the keys to the kingdom or keys to the cloud service provider tenancy, what you're using. It's your responsibility to safeguard those keys as well. Over to you, Brita.
Excellent. Yeah, these are big questions. Hard to hit in a little short segment. So, final question for you in this segment, which is, how can organizations gain assurance that the service provider's side of the shared responsibility implements appropriate controls? Are these controls verified and audited by independent third parties?
Absolutely. So any cloud service provider, given a time, they had to comply with a number of these regulatory bodies, the compliance body in the industry-specific requirement and all. And we have a principle, right? We call it trust but verify. Now, being a cloud service provider, it is very hard to allow each and every organizations to come and audit you if they have a third-party security assurance framework. However, there are organizations, giving an example of Microsoft, of course, you have a right to audit, but you need to subscribe to that right and go and do the audit. Otherwise, there's a concept of trust but verify, where cloud service provider is hiring an independent auditor. It could be from one of the big four organizations or could be a regulatory body themselves. They come and audit against all those control framework, could be ISO, PCI, APRA, and GDPR and whatnot. And these independent audited report are being hosted on a public repository site. To give an example, Service Trust Portal is one example from Microsoft side, where they can go and download those assessment report and certificate, which are independently issued by the third-party auditor, and they can verify which controls are tested and being responsible from CSP side, and which are the control which when our customer is responsible for implementing, if they need to comply to, for example, NIST 853, right? 1,000+ controls in them. But if Microsoft takes care of, or a cloud service provider in this case, takes care of 63 to 73% of the control, but the remaining part is you need to focus on, because those control, as I was talking about during our shared service model, they can't be taking care of that. It's your responsibility in that area. And there are mechanisms such as the secure scorecard, where you can go and have a look at what is the current compliance for my environment or my tenancy or my subscription, which can give me a visibility of all the control which are being passed by the cloud service provider, and which are the control which I need to focus on. So trust but verify is something, a principle which all the cloud service providers are working towards. Over to you, Brita.
Excellent. Okay. Thank you, Abbas. Miles, I'm going to bring you into the conversation here with the next 3 questions, reminding our participants that all of our panelists are in the chat area. Miles, a question for you. For security controls that the customer is required to implement, what sources of best practices or industry frameworks can CISO teams leverage? NIST CSF, CIS Top 20, PCI, DSS, etc.
Thank you, Britta. So yeah, cloud control frameworks. This is a very interesting topic that I spend a lot of my time at the moment talking with CISOs and security teams around the region on. And I think if we go back kind of, many years, the focus of the security teams was ensuring the trust and verification, as Abbas has just been talking about, understanding that the cloud is secure, understanding the controls that the cloud provider has built for you and has audited. And I think once an organization has kind of gone through that process, then it's really time for them to start thinking about how to build their own control framework that is suitable for the cloud. So while each cloud provider will have prescriptive best practices that are specific and unique to their platform and services and unique capabilities, a sensible approach for a CISO, I think, is to build a control framework which uses a common set of controls or a common set of control objectives. So things like assets and software should be inventoried, or data should be encrypted at transit and at rest. These are some good examples of control objectives that are kind of platform agnostic or holistic across technology providers. And they aren't specific to a particular vendor, but they do provide a good security outcome. Now, organizations can build a security standard with these control objectives that can be used across their organization with a single taxonomy and nomenclature. Everybody knows what control, one should be doing. And these controls then can be adopted across your different technology partners, your different cloud providers, and also different types of cloud as well, whether that's infrastructure as a service, platform as a service, or even SaaS. So let's say as a CISO's team, you've developed kind of a list of these 100 common control objectives. You don't really mind where the data in the system lands. If the business has a business case to move it on a particular platform. But what you do really care about is that those control objectives are filled and completed, okay? So if you have, that example of data must be encrypted, addressed, and in transit, it shouldn't be acceptable with one platform, you can't achieve that, or in a particular SaaS platform, you can't achieve that. If that's your objective, to protect the confidentiality, integrity, and availability of the data, then we need to make sure that there's a method to do that, or you have mitigated controls and a risk management framework otherwise. So for organizations following this kind of control objective approach, where can you get started with a list of sensible common control objectives? Well, first of all, this will largely depend on your organization and what various obligations and requirements that you have. So those obligations may come from a variety of sources. Typically, organizations will have obligations from their existing on-premise or internal policies. So you may have an access control policy that stipulates, all privileged access must use multi-factor authentication, for example. You might also have policies around data protection, which mandates what sort of ciphers and keys and algorithms are used in your organization to protect the data. So there's definitely a set of obligations that you already have to meet. Secondly, you very likely, if you're an enterprise, have obligations potentially from a regulatory body. So here in Singapore, for example, you would have the Monetary Authority of Singapore, which has the various guidelines around technology risk management, outsourcing, and more recently, the cyber hygiene notice to ensure that you're uplifting your security posture. As Abbas mentioned earlier, obviously further in the region, in Australia, there's definitely requirements coming out from APRA and other financial regulators around the region. From an industry perspective, you will have obligations and requirements from things like PCI DSS, if you're in the payment card industry, or even HIPAA, if you're processing healthcare and medical records. So another common approach is to leverage industry frameworks like the NIST cybersecurity framework. So the NIST cybersecurity framework provides 98 control objectives across 5 core security functions of identify, protect, detect, respond, and recover. So there's going to be a really good place to start for organizations. If you've collected those 3 different groups of requirements and obligations, you can start thinking about your common set of control requirements. So there's going to be a lot of overlap against those 3 sources as well. So for example, in your internal policy, I suspect that you have requirements around encryption. In your regulatory requirements, there will definitely be, data must be encrypted, and certifications like, or programs like PCI DSS will also require for encryption. So in your control framework, you could essentially have a single control that says data should be encrypted, addressed, and in transit, which effectively meets a wider set or one-to-many relationship back to your control frameworks. So once you have a well-defined control framework with holistic control objectives, it will then be time to ensure that these controls are defined, built, and operating effectively for your platform of choice. At this point, the implementation procedure will become platform specific. So I've mentioned a couple of times the example of data protection. Of course, you can encrypt your data across all platforms that we're talking about here today, but how you specifically do that will depend on the platform that you are choosing and also the service within that platform. So for example, the way that we do encryption at Amazon on our Amazon S3 object store will be slightly different to the way that we do it on our relational databases, for example. So it's important for security teams, I believe, to not only provide the control objective frameworks, but work with the application teams to ensure that they have the procedures kind of detailed out to how to effectively enact that control in the cloud. I think it's also important, as Abbas has mentioned, and Mark and myself a couple of times now, that there is this shared responsibility model. So although you may have your entire kind of control framework, many parts of that control framework might already be completed by the service provider. So things like physical security, potentially denial of service, physical security of the data centers and the global platform. You still want those controls to be there, but you're not responsible for implementing them. So very important to remember that. And finally, for controls that need to be implemented by your organization as part of your responsibility model in the cloud, these can often be split into two different groups. So preventative controls and detective controls. Preventative controls in the cloud are usually enforced using identity and access management, which I'm going to talk about in a moment, that really prevent your users from making misconfigurations and introducing risk into your environment. And detective controls are typically the result of an event-driven security posture where you're using the visibility and real-time automation that I mentioned previously to detect these events as fast as possible and mitigate them using cloud-native technologies. Thanks, Britta.
Okay, let's go identity. My roots are in identity, so I love anything in and around identity. So why is identity so important in a public cloud environment? What are some best practices to consider?
Yeah, good question. And I think it was really interesting what Abbas mentioned earlier around seeing a shift in CISO's kind of organizational structure to start hiring kind of identity architects or cloud identity architects, because, it is such a primary control in the cloud. So yeah, as I previously mentioned, when we split these control frameworks into two, you typically will have your preventative and detective control in your public cloud environment. And let's talk about why that is so. So first of all, if you wanted to build a new system in an on-premise environment, you would kind of initially go into your data center physically. You would physically rack and stack the, potentially the hardware and your machines. You would physically connect it to the network, potentially bootstrap an operating system and the application technology stack, and then finally kind of add users and integrate that operating system and application to your wider Active Directory or your application user base. So historically, identity has been one of the last things, still very important, but one of the last things to do in a configuration or environment. Now, in a cloud environment, identity is typically the very first thing that you do. You need to sign up to your cloud provider's kind of console or web application, and then you create users that can access your service provider's control plane. And then you permission those users to access resources and deploy servers and operating systems and modify the network. So in the cloud environment, identity is typically the very first thing. And it's really critical to get right to ensure that you enforce best practices like separations of duties, principles of least privileges. So talking more specifically about some best practices then, I think, and something that I see successful cloud migrations is when you have a central identity provider to manage your users in a single location. Ideally, you would use this identity provider across platforms and third-party applications, including SaaS. This makes it easier for your employees to interact with the cloud. They only have to remember essentially one set of credentials. And there's also benefits for the security team here in that, first of all, as I mentioned, users don't write down multiple different passwords or share passwords across multiple different providers, which might introduce risk from a data breach of, potentially one of them. But also you have the ability to very easily interact with your existing kind of movers, leavers, and joiners processes. So if someone was part of your cloud team and then maybe moved roles or left your organization, typically it's very easy then to just deactivate that resource in a centrally managed IDP, and then the access to the cloud environment would automatically be revoked. So there's definitely some upside and benefits in having a central identity provider to manage your users and resources across your platforms that you're using. Of course, another best practice very quickly is to make sure that you're using strong authentication mechanisms, so strong and complex passwords, and also multi-factor authentication to ensure that your users are authenticating securely. Now, typically that would be part of your identity provider's capability also. So once you have a centrally managed identity using strong authentication mechanisms, I think it's then time for organizations very quickly to start thinking about their authorization model in the cloud. So many organizations will typically either consider a role-based access control model or an attribute-based access control model. So if we talk about role-based access controls models for a moment, that's when you really define permissions around a person's job function. So in an RBAC model, you would define a policy for a particular job function, like a network administrator or for a database engineer, and they would have specific policies that allow them to operate in the cloud environment and access and provision resources. As a best practice, you would grant minimum permissions necessary for the job functions. And of course, this is known as granting least privilege. Now, one of the drawbacks potentially of an RBAC model is that as you add new resources into the environment, the policies from an RBAC perspective need to get a lot more fine-grained and complicated to ensure that even though I'm a network administrator, let's say, as my job function, is the resources that I can interact with at the network level actually part of my responsibility? So really, that's where attribute-based access control authorization strategies can help, and that's where you define permissions based on attributes of the resources tied back to the individual. So typically, attribute-based access control policies require fewer policy or fewer policy maintenance changes. But what I would say is, regardless of whether you go down an RBAC or ABAC authorization strategy, you should be aiming to ensure that users are granted only the required permissions on the assets and resources specific to their business requirements based on the principle of least privilege. The next best practice I'd like to talk about very quickly is just ensuring that privileged accounts are not used for day-to-day or BAU operations. Organizations and security teams should bear this in mind, not just for the access to the cloud provider's control plane, but obviously the operating system and the application stacks as well. A very common approach is to make sure that you are vaulting these privileged credentials in some sort of identity store or privileged access vault. And then when your employees need these privileged credentials, they have the ability to devault them, potentially using an authorized incident management ticket or a change ticket, which documents the actual steps that they plan to take when they move to the cloud. Finally, what I would say is making sure that you're obviously auditing all of this access. So, for example, when people are interacting with the cloud resources, making changes in your environment, defaulting privileged credentials across your environment, or even using other secrets, whether that's API keys, database credentials, and whatnot, from an identity perspective, making sure that you are constantly logging and monitoring that. And I think that concept of visibility, you've heard me mention a few times, and I know the other guys also agree that visibility is one key benefit that you're going to get from the cloud environment, which really empowers security teams and CISO teams to have a very proficient security posture.
Excellent. And you can't talk identity without talking privacy, right? So final question to you would be in and around, how do CISO teams protect PII in the cloud? How do cloud providers provide the capability to protect an organization's most sensitive data?
Thanks, Britta. So yeah, of course, organizations are going to be moving critical systems, sensitive data, PII data to the cloud, and they're going to want to protect that, obviously from a confidentiality, integrity, and availability perspective, but also, privacy concerns, ensuring that, global regulations like GDPR or PDPAs around the region are kind of catered for and met. So cloud providers provide a number of layers of controls to protect sensitive data, typically using a defense in depth approach. This can include things like data classification techniques that you can classify and your data to determine what is sensitive data, what is PII, potentially using simple things like tagging and adding metadata, but also using potentially machine learning and classification services that allow you to automatically detect where sensitive data is inside your organization. Secondly, in terms of defense in depth approach to data protection, obviously I've just talked about access control and identity. That is definitely a key control when we talk about ensuring that only authorized individuals in your environment have access to the data, the resources, and the systems that they would expect. And then obviously we have encryption capabilities, which is sometimes seen as one of the primary controls to data protection. And of course, you want to be thinking about your data encryption both in transit and at rest, okay? And then finally, I think, and I'm going to go and touch into a couple of these in a little bit more detail, finally, from a data protection perspective, and sometimes I see organizations overlooking this as a control, but it's what is your data backup strategy to ensure that if you do get hit with malware or ransomware, that it doesn't have the ability to totally, affect the integrity and the availability of your data by, encrypting it and holding you ransom for Bitcoin, or for modifying the data in a way that makes it unusable. So there's definitely a need to think about your data backup strategy. So I want to dive a little bit deeper into encryption in the cloud. So customers may choose to encrypt their data for a number of reasons, first of all. Obviously, initially, they want to protect the sensitivity of their business data, or PII, both from the cloud provider themselves, but also internally in their own organization. A very common attack across enterprises around the world is an insider threat, where you essentially have an insider with overly permissive access to a database, has the ability to do large-scale data exploitation and steal millions of records of PII. So you want to think about controls at multiple layers when we talk about encryption. In addition to just it being a really good control to protect against, implement security, also organizations have a requirement to implement encryption from regulatory perspectives. So again, if you're a financial institution, your regulatory bodies would definitely expect that sensitive financial transactions and PII is encrypted. Also, if you have any industry certification requirements like PCI DSS, or you're going through any other compliance programs, you're going to have to demonstrate that you're protecting data, and of course, from a privacy perspective. So cloud providers already provide multiple layers of data encryption, as part of the shared responsibility and as part of the global network. So the cloud provider may provide the encryption of the data as it moves around the global network between, what the cloud providers would call regions and availability zones and the global infrastructure. I would also provide encryption at certain layers of the network stack. So as the data is moving around the virtual private network and the virtual private clouds, ensuring that the data is handled and encrypted in an appropriate way. And also the cloud providers may encrypt the data at a host-to-host level, or a virtual machine-to-virtual machine level, to ensure that it's encrypted at that layer. Now, in addition to the protection and the encryption capabilities offered by the cloud provider, you also have the ability to use, as a customer, to add your own encryption capabilities over the top of that. So typically, you would have the ability to use your cloud provider's native capabilities. All cloud providers have the ability to use hardware security modules that will encrypt your data at rest, where you have the ability to potentially manage the key, the life cycle of the key, the administration of the key, and assign that key permission across your organization to determine who can actually access that data. And in addition to encryption of data at rest, you also have the ability then to go kind of one step further and introduce something like column level encryption. Again, either using the cloud provider's native APIs that they have, or as Mark mentioned earlier, cloud providers have a very extensive marketplace of third-party partners. So if you want to use the cloud provider's native encryption and you want to complement that potentially with a third party, or you want to do kind of column level tokenization, data masking, and anonymization, there's a very wide and healthy partner ecosystem that can help you. So I mentioned earlier that having a data backup strategy is very important to protect against malware or ransomware that may affect the integrity, but also the availability of your data. And of course, one of the benefits of cloud that the team outlined earlier is that you do have the ability to store data in a very highly available, highly durable locations using the global network, the global regions, and global availability zones. You also have the ability to enforce, protection settings on your data. So you can have things like version control or write once, read many settings, or typically known as WORM, which provides organizations the ability to protect kind of critical backups against deletion for, time-bound periods or indefinitely, if that's what you want. And this is a really good control to protect against ransomware overwriting data sets, making it inaccessible to your organization. Finally, again, I want to talk about, to close the data protection question, is how important it is to ensure that you, as a security organization, you're leveraging the cloud native auditing and login and monitoring solutions around this. So because everything in the cloud is essentially an API call that is being logged, you're going to get very fine-grained transparency into your data access and operations on that data, including encryption operations, decryption operations, if the data has been moved elsewhere, who the data was moved by, who the data is frequently accessed by. You can get very, very fine-grained login and auditing across your data access, which the security team gets a lot of visibility and is one, again, I keep saying it, visibility is an amazing benefit of public cloud providers. So thanks, Britta, and then I guess over to Britta and Mark.
Actually, that was a wonderful setup. Mark, I want to pull you into the conversation now, and let's talk about visibility. That was a really good leverage point there for Miles. Thank you. Mark, as a CISO, I often hear that I cannot get enough visibility into my cloud environment, and I'm unsure what the application teams are doing. Is this true? How do cloud providers provide this visibility?
Thanks, Britta. And not to cut it short, because Miles certainly spoke how the visibility is strong in the cloud. But we've heard this before. It was easy on-prem. You held the keys to the change approval board. You didn't open the firewall rule to allow releases to move from environment to environment, to all the approvals and the security reviews were completed. And this is why the business wants to move to cloud. Speed, innovation, competition, a lot of that comes from the developers and the application teams. For us in security, the developers keep introducing new ways and new things, languages we haven't run or pen tested before, Rust, Elixir, Kotlin, new words we haven't heard, libraries we haven't vetted for production usage, some open source that we may haven't included before, deployment packages that we're not sure and understand how to monitor, like a Kubernetes containers or a container-based workload. So in part, this is true because we never really provided this somewhere else in the business, where we could quickly and elastically deliver services. But the cloud is tooled by default to provide this security and visibility in a way you didn't have on premises either. Such things as default identity and access management. You have logs of all admin activities and the service accounts and their communications by default. Strong identity and access management can limit application teams to only do what they should be doing. An org policy with a hierarchical firewall rule protecting the infrastructure should not have the permissions of the application team to be overridden for their individual project. One example of the strong control that you can have and management. Another area would be data storage. We've spoken about that with the PII classification, with Abbas, and through what Miles has spoken about. It's centrally managed, can be scanned for PII and sensitive business data. And the usage and monitoring of that is all tracked and logged with detail. Infrastructure logs, creation of subnets, IP addresses, VPCs, all exist by default. And networks can easily have flow analysis or full packet capture enabled to allow you to do deeper analysis of changes in the environment or what application teams are doing and using in that space themselves, without the need for specialized hardware, traditional span ports, and challenges that are associated with NetFlow devices. And service accounts. One of the major banes of existence that we've had traditionally in security are hugely monitorable in a cloud environment. Revocable, understandable, highly auditable, and there was also a mention of managing the keys and vaulting and IAM around that. This is also very powerful capability to understand how your system-to-system interactions are occurring and monitoring those application teams' norms of communications with their systems and services. And last but certainly not least, is there's a bunch of native compliance and benchmark analysis that can be built in to give you some industry best practices that Miles had mentioned earlier. So cloud can actually give you some native analysis of whether you're meeting some industry standards like a CIS benchmark analysis as well. So these are certain areas that great visibility can be added to the environment. It exists natively in cloud, and it's a matter of applying it to a new way inside the way you operate. Thanks, Britta.
Thanks, Mark. So going back to actually the very beginning, the introduction, when you had talked about automation, let's dig a little further there. Why is automation so important from a security perspective in the cloud, and how can it be used to increase an organization's ability to effectively respond to incidents faster than on-prem?
Sure. Yeah, it is a common challenge that we have. And a constant thing with cloud is we're moving faster, which means change is faster. And the traditional analogy of a car that goes faster and needs bigger brakes. it really isn't just that simple. You just can't put bigger brakes on. It doesn't work like that. You're actually not actually creating the outcome you want, which is to go faster with more safety. So I more consider building security controls in the cloud to be more like the anti-lock braking system on a car. It helps when you make a mistake. It can lessen or even possibly prevent the crash from occurring, but it's able to detect something that's gone wrong in the situation and act on that. This type of intervention is only possible through automation. It's too late to retrain the driver, and they're out of control in production. How do we detect, immediately identify, and start to work on remediation in that space? Automation is key, and it must be built in from the beginning so that you're equipped with those tools when the developers go out building applications and leveraging the elastic services that cloud provides. The DevSecOps concept as a guardrails, not gates concept. You can't scale to your security team to meet the many different inspection points that you traditionally had with a UAT to staging or staging to production release cycle with those change approval boards I mentioned earlier. Developers now experiment in production, release in production with blue-green and A/B and canary testing methodologies. How do you enable that safely and manage that? Automation is going to be key to detect any anomalous spikes, any particular challenges, and responding to that while you're actually doing testing in production. So where do you start? Well, actually, it starts with the power of cloud, the asset inventory. Everything in cloud is a digital asset, a firewall rule, an IP address. By monitoring assets, resources, and policies in the cloud, we can actually build our anti-lock braking system. These are norms that are simply incorrect for an environment. Let's go for an example. Creating a virtual machine. You can first test if it came from the SOE or Trusted Image Store. Is it approved? Does it have a public IP address? Has it been scanned for the latest vulnerabilities? Does it need this public IP address? If it does, is it exposed behind the load balancer, the web application firewall, and is it accordingly only able to be communicated from the back-end IP addresses of that? This is a very simple litmus test to create a mitigation control for a web application. And if it had a firewall rule of any to the internet, we immediately have a problem, and our anti-lock braking system can kick in and start to mitigate that particular risk. Now let's talk about some data. PII is something that we're furiously protecting and making sure we monitor and manage in every environment to protect our customers. When you upload data to the cloud, you can go through a quarantine. You can only allow data to be uploaded in one place that checks whether or not that is the right place, right information for the right use case. Should PII be in a public store? Equals no. And so therefore, every time you add information to a store, you can check whether there's PII, and you can check the permissions if they're public or not. And this can create that, again, anti-lock braking mechanism, that continual monitoring, that continual alert that will allow them to upload much data as they need to do their job, but create safety nets and controls not to mitigate risk. So I think they're two fairly strong examples of how only automation could really solve the problem, because the scale at which we build infrastructure and the scale at which we move data today, no human can watch any of that. Back to you, Britta.
Excellent. And a final question for you, Mark, in this segment, and then we'll bring all our guests back for a parting question. How can the cloud help me implement security at every stage of the software development lifecycle?
Yeah, this is a really, really big question. And there's lots of approaches and different names. Some call it shifting left on security, bringing security earlier into the SDLC, the software development, the AppSec lifecycle. DevSecOps, as I've mentioned just prior, making everyone accountable across both development and operations for security being built in. Or building cloud native, moving from a traditional model to a cloud native security model. What are you going to need to do? Well, as a CISO, probably a little bit of everything. That's strategically moving to an improved security quality no matter what you do. And building an environment that will migrate most of your services to in the future that supports these principles, which is likely to be cloud native. So how important is it to do this? So in one of the State of DevOps reports, or DORA reports, it was found that high-performing organizations were doing 50% less time remediating security than low-performing organizations when they got this right. So it's extremely important in that resource optimization and in the ability to improve the security posture of your applications and the systems that you run. So shifting left in the security review process to early in the system development lifecycle requires several changes, but not all of these are significant deviations from the norm. You should get InfoSec involved early in the software design. The InfoSec team should get involved in the design phase for all projects. When it begins, a review can be added as a gating factor for releasing the design to a development stage. You can develop security-approved tools, providing developers with pre-approved libraries and code packages that have input and predetermined approval from the security team to standardize developer code. This makes it easier to review the differences instead of the core, which you know can be reusable. You can develop automated testing. The cloud's really good with this. Using that asset management database I spoke about earlier, changes in the environment can trigger scanning and code reviews. Building security tests into that means code can be continuously tested at scale without requiring manual review, and identify common security vulnerabilities earlier on in the lifecycle for mitigation. So how does cloud really help? This is where platform as a service and containers really show their strength. Cloud brings the same power to development teams and the security team with these services. One great example is something called the service mesh, or like open source products such as Istio. Imagine you can secure every call to every service with mutual authentication and limit these communications only to the right services that are approved to talk to the other services without changing the application. This sounds like a fantastic security tool you can apply across your container-based services to get telemetry, observability, apply security in transit, and understand the norm of communications to give an understanding of what is talking to what when, is it allowed to, and is there anything abnormal happening in the environment. But it's not just about the operational security, it's also about the supply chain. So by protecting interaction to containers is only one part. The next is making sure your images are trustworthy. So how do we do that? You must make sure the supply chain has security and compliance baked in from the beginning. We do two main things here. One we're very familiar with, vulnerability scanning. Container vulnerability scanning lets you quickly understand potential threats and identify issues as your containers are built and stored through the container lifecycle. The InfoSec team is a critical tenet in managing that container image and the vulnerabilities and packages that exist, and the ability to remediate. And secondary, monitoring binaries executing with binary authorization. Open source capabilities exist for this to provide the services you can use in the cloud to provide this level of capability in the supply chain and the operational observability. So I think that one's addressed the question, and back to you, Britta.
Excellent. I'm going to bring all of our panelists back now into the room. We've been drinking from a fire hose. There's been a lot of really good material given between all of our presenters. I'd like to address this last question. Miles, if you can start, and then Abbas, and then Mark, you'll have the final words. What are 3 key next steps for a CISO organization to consider when moving to the cloud? Miles.
Thanks, Britta. So the first one for me, and I don't think it was addressed actually through the previous slides, but how important it is for a CISOs organization to establish a training, enablement, and certification program for public cloud security. And one of the reasons for that, I find, is that most organizations, the cloud journey is obviously driven by a business demand, and then a business requirement to move to the cloud for whatever benefits that they're trying to drive. And typically there will be some sort of cloud working group or cloud center of excellence, which is largely an engineering team or an application team driving that. Unfortunately, sometimes the security team is maybe not initially part of that cloud working group or that kind of cloud center of excellence. And maybe the security organization hasn't had time to fully adapt their existing tools, capabilities, and processes, and even thinking around security for the cloud. So I think as a CISO, it's very important to ensure that you have a line of sight on skilling up and reskilling the team on the new aspects of security in the cloud. Now, yes, there is going to be existing tooling and existing control objectives and principles that you're going to bring with you. But as you've heard, I think, from all three presenters today, there are slightly different ways of thinking about that. So my first consideration for a CISO's team is to look inwards at your own organization and evaluate what actual capability you have around public cloud security. It's going to be very difficult to do the rest of your job functions, whether that's architecture reviews, engineering, security operations, if your own organization really doesn't fully understand the public cloud security principles, and also what the objectives are of the business teams that are moving to cloud. So for example, if your organization's ambition this year is to migrate everything to a cloud provider and move kind of all in and close the data centers, your security capability and enablement plan will look very different to an organization that's just trying to get started with POCs and maybe non-critical data and systems. So I think the first one is to establish a training and enablement. Similarly, on that, sticking on that suggestion for a moment, I would also look inwards and have a look at who within your organization is the single-threaded leader for cloud security. So if it's kind of a little bit of a hobby of everybody's job, that's maybe okay for now. But what I do see with organizations that where cloud security is a second-class citizen or it's not someone's full-time job, then there's no real ownership over driving some of these strategic programs that you're going to need. The second consideration that I would say is that organizations, as I've mentioned kind of in length in one of my questions, was around how important it is to build a control framework for cloud. So for example, if an application team kind of puts their hand up and says, we want to move to cloud, security team, what do we need to do? I think there needs to be a very clear, defined set of obligations and control objectives that need to be built. I do see a lot of customers spinning a lot of cycles and the security team kind of being really challenged when there's no real clear path forward or clear set of requirements for the application teams. Now, in most organizations, the application teams are very willing to build those control requirements into their application technology stack, but they need to be defined first and really kind of confirmed with the security team. Then I would think a CISO should also take that a step further. So a really good place to start is to have a well-defined control framework that all of the application teams across your organization are aware of. It's been communicated, it's been agreed upon. But in addition to that, as I mentioned, the actual control implementation or the control procedures that are specific to the cloud, I think successful security teams actually go that extra mile and work kind of hand in glove with the engineering teams to come up with solutions to actually ensure that those control objectives are embedded into the application's development lifecycle. Mark talked about shifting security left and DevSecOps principles around that. Now, I think the security team can really lean into the engineering and cloud working groups there by providing subject matter expertise as to how those control objectives really can be built into the pipeline to ensure that those controls are constantly audited or prevented or detected in real time. Then the final consideration of the three that I would say is that organizations, and particularly security teams, really need to embrace the visibility and automation benefits that you get in. If you don't have real-time visibility into your control framework, or if you don't have a real-time security operations setup where you have immediate notification when a high-risk event is occurring in your organization, then I think there's a little bit of work to do for you as a security team. As I mentioned many times, the visibility that you get, not just from the native control plane, but across all of the login and monitoring solutions available to you in the cloud, really does allow you to build this kind of fully automated, real-time responsive security operations center. In addition to that, not just detecting these alerts in real time, but also firing automatic responses to essentially self-heal or self-remediate these incidents as they occur is a very powerful position to be in. So just to recap, train and enable your teams, be prescriptive with your guidance, automate as much as possible. Thanks, Britta.
Excellent. Abbas.
Thank you, Miles, and thank you, Rita. So being a cybersecurity practitioner and being a CISO, I always like to think from a risk management lens point of view. Yes, controls are required, but they are secondary for me. So as a CISO, now that decision has been made that now we need to move towards cloud. So what is my risk management focus is now? I have to focus I need to shift my focus to these three areas. First, being identity. Second, being information protection. And third is my device management. So my cloud security strategy, which I'm building now from on-prem to the cloud, my entire strategy from risk management point of view will be running around these three legs, as I call it, right? In terms of identity becomes my new perimeter. So how I'm going to focus manage my identity in terms of multi-factor authentication, in terms of strong authentication, or even going towards a passwordless journey, right? And how I'm going to manage the least privilege access management and all. When it comes to information protection, now that I have my data shifting from my on-prem to the cloud, how do I manage my information in terms of sensitivity, criticality? We talk about the backup, we talk about encryption, who has access to what, where am I storing those data, the geographical location, the tenancy, the jurisdiction, which country am I hosting those data? All those things has to come up as a part of my strategy. I need to have a information protection strategy apart from my identity strategy. The third being a device, which is on the threat management. Now that my employees are working from home, working from remotely, taking advantage of cloud as an opportunity, especially in this pandemic situation, what controls do I need to think of? Or what strategy do I need to think of managing those devices? Am I going to allow my employee to use bring your own device? Or am I going to allow, how do I manage the handheld device? What kind of threat protection do I need to put on them? So my strategy will shift from focusing highly a network-centric, which is internal, to a more cloud-centric, defining in these three areas: identity, information protection, and device. The second point is, I keep on talking about identity, and we have spoken enough about that. Identity is a new perimeter, right? I can no longer focus on having everything behind the firewall and a network-centric. So now I need to start thinking from a zero-trust network architecture point of view. Zero trust, as I say, is not a technology, it's a strategy and it's a journey. So from zero trust point of view, I need to focus on my core three principles, which is trust no one and verify everyone. So the healthy signals which I am collecting from my identity and my device management, I need to verify each and every signals, because that's how I'm going to get an assurance whether who the person or the device which is trying to access my resources is the right and healthy. In terms of the signals are good, the device is managed or meeting my compliance requirement, the identity which they are using are not being compromised, and the identity which are being used are with the correct security features on them. So trust no one, verify everyone. The second one, my principle which I will go and focus on my identity is my, I call it a least privilege, right? That's another part of my strategy, as I talk about in the first option. Least privilege talks about not giving a standing access to anyone, irrespective of what role they have, even the admin. They should have something like just in time and just enough access, as in based on the need it, or we call it a role-based access control, right? So that's what I need to focus on when I'm building up my identity-based perimeter. And the third principle, which I'll follow in my second recommendation, is having the assume breach mindset, right? I have to have a defensive layer in my control framework, as Miles was talking about. So in case my first control is breached, what do I have the second control to protect my data from getting exfiltrated? So I need to constantly work from an assume breach scenario. Those are my top three within my second recommendation. And the third key takeaway for CISO who is trying to move towards cloud, we had a lot of discussion on shared model. So I want to reiterate that particular third steps, that understand the shared responsibility in the shared model, implement a good governance. Usually things, I would go one level up in terms of roles and responsibility. So as a CISO, I had a team who was managing the network security, the access control and whatnot. But when things go on cloud, there are a number of tools and security features which are provided by your cloud service provider. Now, there's always tug of war between the team, that which team should have access to which security tool provided by my CSP. Is it the network security team? Is it the IT security? Is it the information security? Is it my SOC team? So have a clear definition as a CISO that now that we are moving things on cloud, and now we have the cloud-based security tools and control. Which team is focused on for visibility point of view? Which team is going to focus on managing and reviewing and monitoring those particular dashboard? So having a clear line of responsibility will go a long way for CISO rather than going back and forth, right? And also understand the shift in the role. Shifting the role for the security, that they are no longer doing things manually. There is a heavy reliance on automations and artificial intelligence and MLs and whatnot over the cloud. And the shift also is focused of initially the net security team was focusing more being an author, but now they are shifting their focus to being more of a governance role they are taking. And there is, as our Mark talking about the software development life cycles and agility, so that also comes into your governance model, that how your architecture teams are continuously being involved. The security team is being embedded right from the beginning, or from the design point of view, right when the design has been discussion, to all the way from the testing point of view at every stage. So 3 recommendation: understand the risk management, have a risk management lens, controls the secondary, focusing on identity-based perimeter, which is a zero trust, trust no one, verify everyone, least privilege and assume breach. And third is a shared model, and a good governance should be in place when you're moving on the cloud. Over to you, Mark.
Thanks very much, Abbas. I think of this like moving house. You don't do it often, and when you do it, you really want it to be right. Rarely do such fundamental shifts in technology that change the IT landscape come around. Centralized computing with a mainframe, decentralized with client server, virtualization making efficiency out of central resources, and now containerized microservices, and edge computing extending this, each improving the efficiency of the prior. There are constants in this for security: safe storage of data, secure communications, identity and access, operating systems and binaries. These haven't changed. With each evolution, we see more abstraction of the underlying complexity and higher automation throughout. The common aspects being speed and code. Cloud is an overlay on this. Use it to augment your business needs. This could be bare metal for now, or going completely serverless on the other end of the scale. Either way, get your teams closer to the code. Embrace extreme automation. Own code and systems that developers should never touch, like the standard operating environment of a VM or a container image, or cryptography libraries that only security experts should really be understanding. Abbas spoke about zero trust. I think this is very important when it comes to cloud. How you access and manage those credentials now that identity is the real perimeter wherever you are accessing from. For me, 2-factor authentication is mandatory here. It's now cheap, scalable, and easily applicable to your organization. Please do it. And CIS benchmarks is a nice starting ground for understanding the security posture for what really is going to be a multi-cloud world. Just like each database is different in the way it operates, each cloud provider can be also. Do the education, study, and research to successfully map your controls. I would say the CIS benchmarks is a nice opening door, and tailor it to your particular needs. It's there for most major cloud providers today. And that's it for me. Back to you, Britta.
Excellent. Well, attendees, you just got a wealth of information. I hope you were taking good notes. I hope you were chatting away with our panelists. Very smart leaders in their field. Their contact information is here. Feel free to engage with them. We thank you for joining us today, and panelists, thank you very much.